So very good evening, everyone. So very good evening, everyone. All the people here and those who are on the YouTube. Uh, welcome all of you. I hope you're all doing great. So how is it going on for everyone? All good? Okay. So if you guys remember last time we had met and we were discussing a little bit about motion, and we saw different terms that are highly important when it comes to motion, right? We talked about average speed and all these things. Today we will be talking about a new topic, and this new topic is about motion in plane. Now, obviously, motion that we talked about last class is not complete. Let me tell you, honestly, we have just done hardly 10% of it so far. The rest 90% will be doing in the class. Okay. So all the people on the YouTube also, if you want to learn it completely, the motion chapter and all other chapters, you can contact our team for having the access of the class. There we will be learning. Today, again, I'll be talking a bit about motion in plane. Again, I won't be able to do it entirely, completely, just a little bit I'll tell you. And the remaining of it, more detailed analysis of that will be done in the regular batch. Okay, right. Now, let's continue with this new topic that we have today. This topic is all about motion in plane, guys. Motion in plane is what we are learning today. So I hope you guys can understand from the name itself what is different in today's lecture. It's about motion in a plane and what kind of motion it was last time. The type of motion last time was in a straight line, isn't it? So either let's say things were moving right or left, or things were thrown up and then they were coming down, like you throw something up and it comes down. Like that it was happening. Left right motion was happening. All these were 1D motion because you are limited to one dimension. Let's say when you are going left or right, you are moving along the x-axis, right? So you are limited to x dimension. When you are throwing things up and down, you are limited to just the y dimension. So both these motions were 1D. But now we are talking about 2D motion. Like these were 1D motions, both of them, one dimension. And now we talk about 2-dimension motion, where both x and y will be there simultaneously. X will also be there, y will also be there. How? Well, you can see the motion in 2 dimension simply in the motion of an ant. If let's say on the table you see an ant, she will be moving very randomly. She will be going like this, in this way. So do you realize what is happening? The ant is also moving to the right along the x direction. And she's also climbing up in the sense, moving towards the y direction. So both displacements are happening simultaneously. X and y are happening together. While in previous cases, it was just one at a time. So in such cases, when both are happening together, how do we approach such scenario? Does the method change? Do we have to do something else? Honestly speaking, no, there is no change in the method of solving. Method of solving is still the same. How? Even if you are given a 2D motion, this is by the way a 2D motion, even if you are given a 2D motion, just break it into two 1D motions. And the moment you will break it into two one-dimensional motion, how to solve one-dimensional motion, that you already know. That's what we have learned, isn't it? So every 2D motion will be broken into two one-dimensional motion, and we're going to solve it. Now, question is, how can we break it? If we break the two parts, what will be the connecting factor? After all, the entire motion is happening together, not separately. So what is the connecting factor? So you will realize we'll break everything. We'll break velocities, final velocities, displacement, accelerations. Everything will be broken into two parts, x and y. Only there is one thing we cannot break into dimensions. Can you guys guess? What is that quantity which cannot have dimensions of x and y? Yes, exactly. Time cannot be broken into X and Y. Time is time. Whether you're moving in X, whether you're moving in Y, time is time. There is only one value for time, isn't it? So time will be the connecting factor between the two. So let's try to have some examples over here. The best way to see how these motions are done is when we throw something from the top of a building. So let's say this is a building, and from the terrace of it, we will going to throw a ball, and we'll throw it horizontally like this. So all of you know in what way it'll going to fall on the ground. So it'll going to fall on the ground like this, isn't it? This is how you will see the ball falling on the ground. Suppose we are to determine after what time the ball hits the ground. Let's say when the ball was thrown from the building, the time was 0. Now when the ball is hitting the ground, the time is t. We want to find that time. We are supposed to find after what time it hits the ground. We have been told the height of the building, that the height of the building is 20 meters. So we are asked after what time it hits, and we are also asked how much far away it hits the ground, like this. And all we have been told is the speed with which it has been thrown. The speed it has been thrown is 10 meters per second. That is the speed of projection. Now, how do we approach such a problem? One thing is for sure, both motions are happening. Everybody agree with that? There is Y motion happening. Ball is going downward also, and ball is traveling forward also. Both are happening simultaneously. Yes. So that's why it's a 2D motion now. It's not 1D anymore. So both dimensions have to be dealt separately. In all such questions, my suggestion to students is to make a table that separates X and Y variables from each other. You will make the column from X direction here, column for Y direction here. And now start listing down all the terms that are given to you. Like, let me ask you, what is the initial speed along X? Initial speed means at time 0. So what is the initial speed along X? Can you guys tell me? It's 10 only, because 10 is along the X direction. So it's 10 meters per second. And by the way, this we are considering positive X, and downward also we are considering positive. We are free to choose sign convention. So initial speed along X is known. What about the acceleration along X? Can gravity act horizontally? No, right? So will the ball be speeding up along horizontal? It cannot, because gravity that exists is only vertical. Gravity can't have any effect on horizontal part. So we will going to say that along X, there is no acceleration, 0. What is the displacement along X? How much the particle will travel along X direction? R, right? R will be the displacement. It will be having along X. So everything about X dimension is over. Now let's talk about Y dimension. What is the initial speed along Y? At the starting point, what was the speed along Y? 0. Everyone agrees with that? 0. Because there was just horizontal speed. What about acceleration along Y? Now gravity is there, isn't it? Gravity downwards. Gravity G, which can be taken as 10 meters per second square for calculations. Actually, it's 9.8, but for questions, we can take it as 10. And what about the displacement along Y direction? How much it moved vertically, the particle? 20 meters, the height of the building. From this height, it has come down to this height. So it reduced its height by 20 meters, isn't it? So our displacement along Y is 20 meters. and positive only because I have taken downward positive. Now you see, after listing down things for both the dimension X and Y, I told you can break everything, but you can't break the time. Time will be the connecting factor. So time will be same for Y and X. Time cannot be different, isn't it? So why is Ui 0? So Samiksha, tell me, at the starting point, where do you see the velocity? You see that velocity along X direction only, right? Do you see any velocity along Y? Did ball have anything up and down? No. So that's why it's 0, initial speed. Okay, so we have listed down everything, and now time will connect both the sections, you will realize. So let's see how it will connect. I can see Y part is uniformly accelerated motion. So I can apply equations of motion. If you guys remember that, S equals ut plus half at square. Let me apply that on Y part. Sy is uyt plus half ayt squared. On Y part, I'm applying this equation. S is 20, u is 0. So first term goes 0. Then we have half ay is 10 times the t squared. And we clearly realize that from here, when we solve, time is coming out to be 2 seconds. So using the Y part, we got the time after which the ball hits the ground. The ball hits the ground after 2 seconds. Now the same time we can use for X part and find the displacement along X. Now see what kind of motion is X direction. I'll give you guys time to write down. You may just see right now. So along X, there is no acceleration. It's a uniform motion. Whenever we have uniform motion, how do we find the displacement or distance? Using distance is speed into time. So R will be speed along X into time. It's simply the basic formula. Distance is speed into time. Now we know the speed along X is 10, which has not changed. And the time is 2. So finally, we get the displacement along X as well. So our answer is that the ball went ahead by 20 meters and it hits after 2 seconds. This is how you solve problems of 2 dimensions. Now all of you can write down and then we will move ahead. Yeah, everybody can write down. So all of you tell me when you're done writing. What Ebenezer is asking, sir, can you explain again? On YouTube, he's asking how you got for X and Y. What Ebenezer, what I got for X and Y? The table. I just got it from looking at the condition. Like you can also see what the condition is. So everybody can see again that when I saw the condition, initially the speed of ball was horizontal. There was nothing in y. I just threw it horizontally. If there was a plain ground available, it would have continued to move straight. So I just gave it horizontal speed, not the vertical. That's why initial speed along y is 0, because I did not give any speed vertically. So who gave it the speed vertically? If we did not give, is the gravity that does that. Gravity pulls it down. So we intended that it just move horizontally, but gravity pulls it down. And that's why you see along with the horizontal speed, now the vertical also starts to appear. That is happening due to gravity. Gravity pulls it down. Although there is no one to pull it along x, so acceleration along x is 0. And vertically it falls by 20 meters, so 20. And horizontally it moves by r. So that's how we get it. Now let's try some more problems. Now this motion in a plane is very much important in real life also. You see it around everywhere. You see it, as I told you, if you see the motion of the ant, you see it, it is like this. But there are some motion which happens when you throw the object in air. Then also something really interesting happens. Sir, what if we take y as negative? Then everything along y will be negative and the signs will cancel out. It will be of no effect. It'll be back to the normal. So now here you saw motion in a plane. Now I would like to talk about motion where we'll be throwing things from the ground into the air and we'll just leave them with the gravity. Just gravity will going to have the effect. So we will just project and let the gravity decide. Like in old age, ancient times, when the wars used to happen, there used to be cannon. If you might would have visited some forts in India, they still have those ancient cannons which are deployed on the top of the fort. So have you guys seen how the structure of a cannon looks like? So there's a huge wheel, the two wheels are there, and then the muzzle comes out like this. And from the end, obviously, they are a little thicker because that is where you load all your gunpowder and explosives. Isn't it? So that's how actually a cannon looks like. And it can easily be moved. And from the rear, they actually put the gunpowder, first of all. A lot of gunpowder is kept. And then you have a huge metallic ball, which is also filled with explosive. Now they just lit up this gunpowder. And because of that, what happens? A huge thrust is created in the cannon because of the blast. It's like similar thing happens in guns also. And this thrust suddenly caused this ball to travel really fast. And finally, it comes out of the muzzle. And then it travels all the way in the air and falls. This cannon is kept on top of some fort. So I hope everybody understand this thing, how it happens. And then it falls on the given target. So any army which is approaching the fort will be destroyed due to this cannonball. Okay. Now see the kind of motion that this cannonball is doing. Do you guys observe that? It is a motion where the cannon was projected from the ground and now its motion was entirely taken up by gravity. Gravity was taking care of rest of the motion. Yes. Now these kind of motion where we project the objects. What we have done, we have projected the cannonball. Any kind of motion where you project the objects is called as projectile motion. So what do we name it? Projectile. So don't have a fallacy that projectile motion is always 2D. Even if I project this pen upwards, and it falls back into my hand. What is that? That is also projectile motion, right? Now this is the projectile motion in 2D. That's the only difference. Projectile motion can also be in 1D, like throwing a pen up and it comes back. So projectile motion in 2D is what we want to learn. This time we'll be throwing things from the object. We have already thrown ones from the building, right? Now let's try what happens if we throw from the ground and they come back on the ground. Before I go into that part, I would also like you guys to solve one more problem similar to the one that we took here, that from the top of the building, I projected a tennis ball, right? Instead of that, let's visualize some real life phenomena. Real life phenomena is that, let's say a flood has struck some area and the entire region is flooded. And now army is there to help everyone and they are supplying food packets. And here we see the chopper of army. So I'll try to draw a model for the chopper. Maybe this is how we can say the chopper looks like a toy helicopter. So you can understand this is a chopper, and on the rear also there are blades, fan. Okay, now this army helicopter is supplying food packets to everyone, and there are people on the ground. There are people on the ground here. The chopper suddenly sees that there is a person in the need standing on the ground, and he desperately needs that food packet that we want to supply. But obviously the chopper is moving at a really fast speed, right? It is moving with some speed u. So what is u here? The speed of the chopper with which it's moving. Now, let me first you ask, theoretically, should the chopper throw the packet right now itself so that it reaches the person? Or should they throw the packet only when they reach the top of the person, just directly above the person? Question is clear. Should they throw the packet well before so that it reaches the person, or only when they go at the top of the person and then throw? Now only, right? They must throw it now. We all understand the reason why it must be thrown now. Because if any packet is thrown from this chopper, let's say a food packet is, even if it is dropped, even if I drop a packet, the moment it will come out, it will also have the speed u horizontally. Because right now it was a part of the chopper. That packet was sitting inside the chopper. It was also moving with the same speed, right? Now suddenly you removed it. The moment you removed it, for the timing, it will still have the same speed. Yes, only for now, it depends upon the speed of chopper. No, irrespective of whatever is the speed, Jay and Jainil, you would have to throw it before. As long as the chopper is moving, you have to throw it before. So think about it, guys. Now the chopper has released this packet. The packet will come out with the speed u horizontally. Now, after that, it has nothing to do with the chopper. Chopper will going to go away. This packet is entirely in hands of gravity now. So what gravity will do? It will try to move ahead as it is doing, but at the same time, gravity will pull it down. So the kind of motion it will do is like this. Just like that ball that was thrown from the top of the building. Now, suppose I tell you that this chopper was at a given height. The given height, let us take as capital H. And the initial speed, let us take as u. Just take the gravity as g only. Don't substitute its value. Keep it g itself. And you guys have to determine that how much distance before, like if the person is standing here, then how much distance before should the chopper release the packet? so that it is able to reach the person. Question clear? Like, why not releasing it from here? Or why not releasing it from here? How will we decide? We'll decide it by calculating the distance. From how much far away the chopper should release the packet. So try this problem. So I can see few answer, and I can see the answer of Shreya is correct. Samiksha is also correct. On YouTube, I can see that Rohan S has answered correctly. Rest of you, please think. It's the same problem as before. What was the method I told you? Separate X and Y. Draw the tables for X and Y. It's exact replica of previous problem. Yes, Shivang has also answered correctly. The rest of you, why are not able to solve? Because it's very direct. Previous problem, similar. There was a ball thrown there. Here, we just have thrown a packet. No difference. How can somebody not solve this? No, Akhil, we have not been given time here, Akhil. So our answer can't contain that. Okay, so I think I should solve it now. So what do you see here? You see the same thing if I make the column. What is the initial speed along X? It's U. Do you guys see that? It's going with U speed. Yes, Siddharth, correct. That is our X direction, and this is our Y direction. So initial speed along X is U. Initial speed along Y is 0 again, because the packet was just thrown horizontally. It was not given any speed along Y. Acceleration along Y is gravity. Acceleration along X is 0. Horizontally, there is no effect of gravity. How much it will travel along vertical? So it will come down by a height of h. So h is the distance it traveled vertically, displacement I should say, and how much displacement it covered along x. That is what we need to find, d. So now what we will do, time again is the connecting factor. So what we'll do, just apply s equals ut plus half at squared in the y part. S is h. So let me write the equation first in case some people get doubt. They might think where this equation has been applied. So I will just apply s equal ut plus half at squared. S is h, u is 0, half g t squared. What is the value of time we are getting? Cross multiplying the 2 on other side, dividing by g, we can see it as root 2h by g. So we got the time after which the packet hits the ground, but we needed the distance d. So I know the same time can be used in x part also. In x part, I can simply apply distance is speed into time, u into t. What is u? U is given as u only. What is t? So time we have just now found out, root 2h by g. And that's our answer. This is the distance before which the chopper must throw. No, Samiksha, you don't use the final velocity because that is not required here. In case they will ask you that what is the final speed, then you will find it. Otherwise not needed. Why can't we apply the second formula in x? Because x has no acceleration, Akhil. What is acceleration along x? Even if you apply this, a will be 0. And then you're back to the same formula. Distance is speed into time, which is what I have applied. So all of you can see again, because I feel like the previous problem was also not clear. That's why many people did not answer, although many of you perfectly did that, but some of you did not. So waiting for you all to write down. Please confirm when you're done writing. So I hope everybody done. What about people on YouTube? You're all clear as well. So let's move ahead, guys. I hope you're all ready now for the new portion that I was talking about, where we'll be throwing objects from the ground. So let's say this is the ground and I want to throw something at an angle. let's say it's thrown at an angle theta. So how it'll go? So we all know how it'll go. It'll just go like this and it'll going to fall. This is how, you know, the missiles are also tested, ground to ground missiles, which are projected from the ground, and they also hit a target on the ground itself. They can easily be launched from any vehicle also. Like, you know, there is a very famous weapon system, which the US is highly envy of, and it's S-400 made by Russia. It's an anti-aircraft missile system, and it can be mounted simply on a truck. So the system is so effective, its radar is so effective. So it is mounted like this at an angle, sometimes even vertical. S-400 has this specialty, it can be mounted vertically also. And the moment there is an aircraft detected in the radar, immediately the missiles automatically get locked to that aircraft. So suppose if there is somebody flying over here in this region, and the S-400 system is there mounted on a truck, immediately the missiles will going to go out and hit the plane. So before the jet could attack the site, the S-400 system will immediately destroy it before that. And the reason for S-400 is because it can detect the jet planes all the way from 400 kilometers. Hence the name S-400. So the plane has not even entered the required region yet, 400 kilometer apart, still can be shot down. So similar kind of launching happens for missile also, like ground to ground, like I'm launching the missile at an angle. It's just that one thing is there, missiles usually have their own engines. So after they are launched, they do have fuel. They can move as they want. In this case, I'm just launching a normal rocket, which doesn't have any, you know, it's like mortars you must have heard about. Mortars don't have their own engine. They are just launched, and then they are all on the gravity to do with them. So this is a mortar kind of launched. It's launched with, let's say, some speed u. And finally, it's falling over here at some target. So how do we define the range of the missile or the rocket? We define the range as how much far away it can hit a target. This is defined as the range. There is a maximum height to which the missile actually rises up from the ground. And here I can see this is the maximum height, Hmax. And there is a time for which this missile was in the air, okay? And that's called as the time of flight. So time after which this missile hits the ground. So now we are required to find these three things. What is the first thing we should do? First thing we should do is again make the tables. Here gravity is acting downwards. There is nothing horizontally, as you know. So here also I can make two tables, X and Y. So what is the initial speed along X direction? This is X, this is Y. So the moment we see the initial speed, it is neither along X, neither along Y, isn't it? It is somewhere at an angle. Do you see that? So what should we do then? So if you remember, we learned in the concepts of vectors. In vectors, we talked about taking the components of a vector, dividing it into two parts. In case somebody doesn't understand this thing, that how to take the components of vector, in the regular class, we will be doing that. Once again, we'll be starting right from the scratch. We'll be doing calculus and vector in that. So what we do is we break the velocity into two parts, one component along X and one component along Y. All right, ux uy we can call it, X component, Y component. And those who know the vector, those who don't worry, we will teach you in the regular class. The x component, which is towards the angle, will come out to be u cos theta. And the y component in the vertical direction will come out to be u sin theta. I know this could be a little troubling for the people who are learning for the first time. Don't worry, once you know how it is done, it'll be easy for you. So now let's write what is the initial speed along x. It's u cos theta. What is the initial speed along y? That's u sin theta. U cos theta, u sin theta. What is the acceleration along x? Nothing again. Gravity has no effect in horizontal. In vertical, yes, it does have g. What is the displacement along x? How much far away the missile hits the target? Isn't then the range along x? How much range? Now let me ask you, what is the displacement along y for the entire motion? Can you guys tell me? Okay, so I can see only one correct answer so far by Shivank. Just see displacement along y. And on YouTube also I can see that Ankit Amin has answered correctly. The answer would be 0. Yeah, here Shreya has also answered correctly. Answer would be 0. You guys understand about displacement. See, if my hand is the axis, right, the ground. So missile started from that ground and finally it touches the ground again. Does it remain in the height? Does it remain in the air? No, finally it comes back to the same ground. So if I ask you how much change happened in vertical direction, no change happened. The change only happened along x. Yes, it was here initially, now it is some distance apart on the same ground. Height change has not happened. Everybody can understand this? Give me a minute. I need to connect the charger on this. Okay, so is it clear to everyone that it comes back to the same ground? That's why no displacement along y. So everybody respond with yes or no if you're getting it or not. All right, so I will write that displacement along y is 0, not h. And now what we will do? Again, we will connect them by the time. Time will be the connecting factor once again. So what shall we do? Just apply the equation as I told you. Apply the equation on the y part. What do we have? S equals ut plus half. I think you all should be familiar with it now. You're doing it multiple times. So put S0. Now u is not 0, u is u sine theta in y. I'm applying it for the y part. T, this is the time after which the missile hits the ground. So capital T plus half g capital T squared. Now, one thing you must realize that if we take direction, upward was positive in y because the speed was upward, then downward must be negative, right? So the gravity that we have taken downward, while substituting in the equation, we must take it negative because it's pointing downward. So here I must place it as negative sign. Everybody understood why it's negative? Because it's downward, and downward is negative y. And so now you can cross multiply. One of the t can get cancelled. Gt squared by 2 equal u sine theta t. One of the t square is gone. And then you cross multiply. What is the time period coming up? I mean, not time period, time of flight. 2u sine theta by g. That's the time.
So why did we take gravitation negative in the before questions?
Why didn't we take it negative in?
Gravitation in the before questions, first and the second.
Before question, we didn't take it because there was no speed in y. So I took downward positive, right? I took downward as positive. Now here what happened? There was a speed in y. Do you see that? Upward speed is there in y direction. So you are still allowed to take downward positive. If you want, you can do it. But then what you would have to do? You would have to take upward as negative then, right? So that's why in order to avoid the confusion, I said, let's take downward negative and let's take upward positive.
Yes,
so
sir,
gravity became negative and u sine theta became positive. So all of you can note down how to find the time of flight. So guys, if this part is done by you all, I have a task for you to do. See, we have got the time of flight, the time after which the missile hits the target. I also want to know what is the range of the missile. So now all of you need to find the range here. So try everyone. What is the range of the missile? Yes, Shreya got it correct. Siddharth, there is only a little mistake in your answer. The rest seems fine. What about the people on YouTube? What is your answer? No, Samiksha, there is. So like, is that u cos theta in numerator or denominator, Samiksha? Yes, Hisham, you're correct. You just need to substitute the value of capital T. Yes, Samiksha, then it's right. Okay, on YouTube, I can see Ebenazir is correct. Yes, Ellen, you are right as well. Yes, Akhil, you are right. No, only with one thing you're wrong, and that's with the gravity in the numerator. There won't be gravity in numerator. Yes, rest is correct. No, Siddharth. Okay, yeah, Siddharth, correct. Okay, guys, so I can see many of you answered correctly because you have learned the method now. In most of the problems, you have done this. When it comes to range, it's about the uniform motion. It's along the x direction. X direction motion is uniform. So the distance is speed into time. Speed is u cos theta and time is t. So let us just substitute the value of time. So u cos theta into, we have just found out the time, 2u sine theta by g. And how much is that? That is 2u square sine theta cos theta by g. That is the range. Correct? Now later when you will learn the trigonometry in detail, you will realize that this 2 sine theta cos theta can be written as sine 2 theta. It's a double angle formula. So you will learn that in trigonometry. Right now we can keep it like this. Let's take the third part as well. So you guys perfectly did the second part. Now I have another thing for you all. Find out the maximum height attained by the missile, Hmax. Now this will require you all to think a little. It won't be that easy. So try what needs to be done in order to find the Hmax. Rohan on YouTube, I didn't get your answer. No, Samiksha, it won't be. No, Shanmukhi. Sisters, you cannot apply that formula in y direction because y motion is not uniform. It's accelerated, isn't it? So in y motion, you would have to use equations of motion, the three equations that you all know. So I repeat, you have to find the maximum height attained by the missile. Please focus that which are the initial and final points for this motion. Initial point is the point of projection, let's say the point A, and final point is this B. You just have to think about motion between these 2 points. What is happening between these two? Even the time t is for the entire motion. You don't need that. You just need for the AB portion. On YouTube, Rahul, that's not correct. Range is something you are all substituting in the formula. No, that's not what you need to do. Ebenezer, that's not correct. And Rohan S, that's not correct. So guys, think about points A and B. So I think it's time I help you all. Should I do that? Okay. Let's just focus on the y part, because we know Hmax is just, it has something to do with y only, not with x. So no, Kishore, that's not correct. So if you see, the motion forms a semicircle. No, Samiksha, it's not semicircle. The kind of motion that particle is doing here is not circle. It's a parabolic motion. And how do we arrive at the fact that it's parabolic? We have to write its trajectory equation, which we'll be doing later in regular class. So there is a proper derivation with which we'll prove that this path you are seeing here is not a circle, but a parabola. Okay, Akhil, you got correct answer. That's right. So guys, let us see motion from A to B. Hmax has everything to do with y motion only. Only we'll see how much it moved vertically, right? So let's just focus on the y part. Don't even focus on x. Just focus on y. Now, if we are just focusing on y part, then let's see what is the speed in y at the point A. So speed in the y at point A is u sine theta. What is the speed in y at point B? Do you guys know? If I throw a pen and when it reaches the maximum height, what is its speed? So try throwing it. At maximum point, what happens? Momentarily, it comes to rest and then falls down. Doesn't it? Do you guys notice that? When you throw it up, its speed goes down, reaches to 0, and then it falls back in your hand. And that is the reason it is a maximum height. I mean, try to think about maximum height means particle didn't go beyond it. It didn't rise above that. If it didn't rise above that, it means there was no velocity to rise. The y velocity becomes 0 here. So at maximum height, the y velocity goes to 0. And at the starting point, it's u sine theta. What is the displacement along y in this process? The displacement is Hmax. It went from A to B, a height of Hmax. So I can see initial velocity is there, final velocity is there, displacement is there, and we need to connect them. The best equation to do this is the third equation of motion. Yes, Kishore, you're right. Third equation of motion talks about v square equal u square plus 2as. Now I'll do this in the y part. What is the final y velocity? 0. What is the initial y velocity? At the starting point A, speed was u sine theta. Finally, it was 0, but initially it was u sine theta. So u sine theta squared plus 2a. Acceleration along y is negative, remember? Downward gravity. And the displacement that has happened along y is Hmax. It rises to a height of Hmax. And so from here, you can see what is Hmax coming. U square sine square theta by 2g. That's the Hmax. So all of you can check if you're getting it or not. Got the correct answer? Okay, nice. What about rest of you? You got the correct? Okay, so now we have everything, guys. We have the time of flight, we have the range, we have the Hmax. Let's try to do a basic question on this, direct formula based. Suppose a missile is launched at 20 meters per second speed. So the speed of launching is 20 meters per second. And we are launching it at an angle of 45 degrees from the ground. So you guys have to determine all the three things. After what time the missile hits the ground, get the value of that time, find out what is the range of the missile, and find out what's the maximum height attained by the missile. All the three things you have to calculate. So try answering in the private chat. Yes, Siddharth got the time correct. So give all three things together, guys. Don't give one by one. When you find all three, you can answer. So Shreya got everything correct. All three quantities. On YouTube, I can see the answers are wrong on the YouTube. Shanmukhi and Rohan, that's not correct. So guys, now you just have the formula with you, right? All you need to do is apply it. That's it. Acha, wait, I just realized that actually Rohan is correct when it comes to maximum height. Yes, Rohan, your answer is right. Shreya, you made a mistake in Hmax. Please check. No, Niranjan, time is not correct. No, Alan, that's not correct. Yes, Siddharth, you're right. Okay, Shreya, you correct now. Akhil, you're correct with the time. Yes, you're correct with other things also. So let me quickly solve this, guys. Direct formula based questions. How do we do it? Well, just see. If I want to find out time, it's 2u sine theta by g. You all have the formulas with you, right? 2u sine theta by g. Let's write it. 2u sine 45. Sine 45 is 1 by root 2. Yes, Samiksha, it is correct. 2u sine 45 by g, which is 10. This is 4 by root 2, or you can say 2 root 2 seconds. Now let's see the range. Range is u square, sorry, 2u square sine 45 cos 45 by g. That's just 40 meters. And now the Hmax. Just now we derived the formula for Hmax. U square sine square theta by 2g. Like this, which is 10 meters. So these are the answers.
So for time, it should be 4 by root 2, no?
Yeah, 4 by root 2 is 2 root 2. Multiply root 2 in numerator and denominator. It's like rationalizing the denominator. So if somebody has confusion, they can understand. 4 by root 2, I multiply with root 2, I divide with root 2. But now I am left with 4 root 2 by 2, which is 2 root 2. So I hope everybody is clear with all the questions we have done so far. Okay, now there are many good questions of projectile still left to be done. And those good questions we'll be doing once the regular classes start. So to all the people who are on the YouTube also watching there, if you would like to have access to those classes where everything will be done once again, and many good JEE mains and advanced level questions will be solved, then you can join the class and we'll see you there, all of you. Okay. All right, guys. So next time also we will be having a new topic, something new we'll be learning, and that's it. So hoping you all to see in the regular class. Sir, when are the regular batches starting? It'll be announced soon, Hisham, to you. Probably tentative date is around 10th May. Okay. 10th May is the tentative date. Okay. So fine, guys. Goodbye, everyone. See you in the class.